All right, everyone, welcome to this video about temperature conversions. Our goal is to convert one of the highest recorded air temperatures on Earth, which is found in the Sahara Desert, as 126 degrees Fahrenheit, into a temperature in Celsius. That is our goal. In order to do this, we must embrace the fact that this conversion cannot be achieved strictly by multiplying with a multiplicative constant. Instead, we need a full linear transformation in which we need to multiply by something and add by something, essentially implementing a linear equation on a graph of Celsius versus Fahrenheit, like this. If we knew the equation of a line on this plot, we could convert input values in Fahrenheit into output values in Celsius. So to help us do that, we need to have some known points on this graph, and we will start by looking at temperatures in which water freezes. So in the Fahrenheit scale, water will freeze at 32 degrees. And in the Celsius scale, water will freeze at 0 degrees Celsius. We can also look at the same here for boiling. So this is going to be for boiling. And here we're going to have temperature in Fahrenheit to be 212 degrees, and temperatures in Celsius will be 100 degrees. So our goal is to now put these essentially two data points, we have 1 and 1, 2 and 2, onto the graph, and then we will try to find the equation of that line. So the temperature in Fahrenheit, let's just put 32 over here. This is going to be our mark for 32, and the 0 in Celsius is down here. So we're essentially going to put a point right here that's going to be 32 degrees Fahrenheit and 0 degrees Celsius. Then we have the second point. Let's just put it over here. This is going to be 212 Fahrenheit and 100 degrees Celsius. Here's our second ordered pair. And essentially by connecting these two together with a line, we were going to have the conversion between Fahrenheit and Celsius. So we now need to find the equation of this line. And we know that any linear line can be expressed as y equals mx plus b. In our particular case here, the y is temperature in Celsius, so we end up with an expression like this. Celsius temperature is equal to some unknown slope times Fahrenheit plus a y-intercept b. Okay, so what we can do is find the slope m. M is always going to be equal to change in y over change in x. So for us here, the change in y is going to be 100 degrees Celsius minus 0 divided by the change in x, 212 degrees Fahrenheit minus 32 degrees Fahrenheit, like this. If you go and divide this out, you will find that it is equal to 5/9, if we want to just leave it as a fraction. Okay, so we have m, we have our slope of this line. We can then go back and find b. Now, one way to find b is by just putting in a point, by using a point in which x happens to be, in which x or y happens to be 0. And so we have this one here, the freezing temperature, where the Celsius, the y value goes to 0. So if we just go back to y equals mx plus b and put in y is 0 and put in x is 32, then we can solve for b easily. So what I'm basically saying is let's do y minus mx is equal to b, and then put in y as 0, and then we're going to have our m of 5/9 times our x, which is going to be 32 at that point. And now we can just see directly that b is going to be 5/9 times 32. So I can even write that one more time here. Minus 5/9 times 32 is equal to B. Okay, so we can now come back to the original equation here, this TC equation. We'll just say TC is equal to our slope of M, which is 5/9, times whatever Fahrenheit temperature we have, plus the slope, but the slope is now minus 5/9 times 32. And we can see that the 5/9 is appearing in two places, so we can factor that out. And you'll have the final formula for conversion from Fahrenheit to Celsius. Okay, so admittedly guys, when you do a temperature conversion, you would not go through this whole process. You would just go look up this formula or just use some formula converter. But now you can see where this formula comes from, and I think that's useful. So let's now apply this formula to our input temperature. We were originally trying to find this temperature 126 and convert it to Celsius. So if we just plug that in, we can do the arithmetic, and the value will come out to 52 degrees Celsius. All right, so there you have it, conversion from Fahrenheit to Celsius. And the key idea is that we couldn't just use only a multiplicative factor, like it wasn't just the 5/9, but you also had to have this other part of a formula in order to be able to do it. Ultimately, the reason for that is because the multiplicative factor takes care of the fact that Fahrenheit and Celsius are different size temperature steps or temperature units, but there's also a difference between the 0 points. So 0 degrees Celsius is not the same as 0 degrees Fahrenheit. Because of that difference, there is the need to have this y-intercept, this offset value. So we need the multiplicative factor and an offset value in order to do the conversion, and this final formula we used just took that expression and factored it. So we didn't have to have the 5/9 repeated in two places. Well, thank you everyone, guys. Thank you everyone for watching this video, and I'll see you in the next one.